Well, hello everybody. I thought I'd give you a little bit of help on the explorations you're doing this week. There are 4 of them, and I thought I'd give you some help on number 1 and give you some hints and get you started. And I'm hoping that by doing that, that the stuff that I get on 2, 3, and 4 will be good. All right, and so we're going to take a look at a circle, and in particular, we're going to look at what's called the central and the inscribed angles on a circle. All right, so you should read the question. Maybe you should pause this video and go read the question and then come back. What I'm going to do is I'm going to open up GeoGebra right now. And I've already taken off the axes and moved some things around here a little bit. But I'm going to make a circle to begin with. So here's my circle. And then I'm going to grab a couple points and put those points on the circumference of the circle like this. And we're going to make a couple line segments. One from here to there, and one from there to there. And now we're going to measure that angle. So this is called the central angle. Bam, bam. Okay, and so the measure of this particular angle looks like is right there. And if I move this around, of course, that changes. Okay, so now what we're going to do is I'm going to grab another point here and put it over here on the circumference on the back side. And again, grab the segment tool. And we're going to connect this guy to this point and that point to that point. Okay. And the angle CED is what's called the inscribed angle. All right, and so if I move this guy around, oops, that guy move. If I move that guy around, I can see there, okay, there it is. That's the inscribed angle. And let me go ahead and measure that one as well. So we measured that one. So there it is. So I do want you to get on Geometry Sketchpad and create this. That would be good. And now I'm going to go ahead and take a look at the ratio of these two values. And you might, as I move this around, you might, take a look at this, and you might notice there's a relationship, okay, between the central angle and the inscribed angle. And I'm going to let you think about that, okay. But as you move this around, you're going to see a certain interesting relationship here. Maybe I'll give it away too much. Oh, there we go. So anyway, so there it is. Okay, and so now how do I go about proving that? Okay, so make the conjecture. What do you notice about the 57.72 and the 28.86? What happens to those angles? And so you'll have to play with that maybe a little bit. And let me go ahead and open up another file here and try to show you how you might prove that and give you some hints on it at least. So I'm going to go, I've got this on PowerPoint. And the reason I'm going to do that is because I'm going to be able to write on it. So let's see, let me change my ink color maybe to like blue or something, I don't know. Okay, and so what we're going to do is, again, here's I'm going to make that inscribed angle again. And I'm going to just kind of give you some hints as all. So let's say this is the central angle here, right there. That's one of the angles I'm interested in. And I'm going to go ahead and draw a segment going from P to O as well. Okay, and so here's some hints. When I'm trying to make some conjectures here and trying to prove these conjectures, I look at this and I say, well, what do I know? Well, I know this is a circle, and I know the radius of the circle is constant. So that means that this segment and that segment and that segment are all congruent because they're all the radii of a circle. Okay, and now you'll notice that the triangle PBC is an isosceles triangle. So that means that this angle is congruent to that angle. Likewise, the triangle POC is also an isosceles triangle because those two sides are congruent. So that means that these angles are also the same. Okay, so that's interesting. And so maybe I'll label this angle alpha. So then this one's also alpha. So the measure of that angle would be alpha. And maybe I'll call this one beta. And maybe call this angle beta as well. Okay, and so then a hint would be, let me change colors maybe for a second to like red or something. A hint would be, I also have formed here the quadrilateral. Okay, and we know that the sum of the interior angles in the quadrilateral is equal to 360. So I know that if I take this angle alpha and that angle alpha and beta and this angle right here and add them together, it'll give me 360 degrees. Okay, so maybe I'll call this I guess I'll call this angle, maybe I'll call this angle, I don't know. What should we call it? I got all these Greek letters, but maybe I'll just call it, you know, well, I don't know. How about, okay, gamma? All right, I couldn't resist doing another Greek letter, I guess. So what can I say? I can say that 2 alpha, right, plus, right, 2 beta, right, plus the gamma is equal to 360. How do I know that? Well, I know that because those are the sum of the interior angles of the quadrilateral. Okay, but I can say something about a gamma too. Okay, because I know that gamma is equal to what? Gamma is equal to 360 minus c. 360 minus c. Okay, and so there's a couple of equations that might help. I think this is where I'm going to leave it. What I like to see if you can do is kind of pull this all together and write it up. And so the other ones, there's some similarities between this one and the other questions I've asked as well. I want you to explore, like with Geometry Sketchpad or whatever, or with GeoGebra, make some conjectures, and then try to justify those conjectures. And so this is part of the justification. And I've not even told you what the conjecture is. You've got to come up with that. But I'm trying to give you some hints on maybe some approaches to take with some of these problems to kind of help you along the way. So I've almost done it, but there's some things you need to put together. So I hope that helps. If you have questions, fire some questions to the homework help folder or send me an email, whatever. And good luck. I hope you enjoy exploring these conjectures this week.